In RBE 3001, Professor Gelly tasked us with a final project, building a pick-and-place color sorting system using the Open Manipulator X robotic arm and a fisheye USB camera. Our team completed this project in 7 weeks. To operate the arm, we needed to determine the position of the end effector in relation to the base. We used forward kinematics to calculate the x, y, and z coordinates of the end effector by assigning frames to each joint and multiplying transformation matrices to attain the overall position and orientation. With a set of x, y, and z positions found, inverse kinematics was used to calculate the joint orientations needed to collect the ball. These coordinates also included an alpha value of 90 degrees to define a set wrist orientation. Once the joint angles were determined, we used quintic trajectory planning in the joint space to smoothly control the robot's motion. The robot moved efficiently by adjusting its speed and acceleration at intermediate points, allowing it to safely collect and separate colored balls.
To identify the balls and their positions, we used a USB camera. Our image processing pipeline included 5 main steps: image acquisition, image enhancement, segmentation, post-processing, and information extraction. For image acquisition, we captured various pictures of the checkerboard and different orientations for camera calibration. For image enhancement, we used built-in MATLAB functions to correct the fisheye distortion, identify the checkerboard pattern, and set up axes for the checkerboard. We also created a trapezoidal mask that cleans up the images by focusing only on the checkerboard and removing the background. For segmentation, we created hue saturation value HSV color masks for each color of interest: red, orange, yellow, green, and gray. We used this color scale to account for the effects of exposure and saturation on the ball. For post-processing, after identifying all the balls of our color of interest, we applied a binary mask to make the balls stand out. We also removed false positives like shadows by filtering out areas that didn't match the size of the ball. This helped tremendously with identifying gray balls.
Once we located the balls centroid in the image, we needed to find the actual position of the ball in 3D. Due to the angle of the camera, there was an offset in the recorded position of the ball that we needed to account for. Thus, we applied geometric corrections to accurately localize the ball's position with respect to the checkerboard. Lastly, the corrected centroid coordinates with respect to the checkerboard were transformed into the robot's base frame. This allowed the arm to understand the ball's position relative to itself and move toward the ball using the inverse kinematics and trajectory planning techniques described previously. Putting it all together. With these parts, the robot can capture an image, detect a ball, and navigate to its location. These behaviors are now combined into a single state machine, so the robot can continuously search for, pick up, and sort balls.
Doesn't have enough time. Honestly, it might actually get there. If it doesn't open up the zipper so quick.